Hello guys, this is Ernest KKK reaching from Lagos, Nigeria. How are you doing today? What we're looking at now is a voltage guard intelligence VGA. So this is just the first phase of the designing the circuit on the breadboard and using some modules on it. Like if you look at this, there's a keypad module on this. So that's what is going on and a lot of testing. And before we go to this stage, we have done the design on paper on a lot and try to get the schematic working and all that. So that's what is going on right here. So you can see there's a schematic diagram for it. We're using a microcontroller which is the Atmega 328. You can see there's two sheets on the schematic, so that's what you can see right here. So this schematic was designed using the design. So we have a timer one, we have a library for the voltage, a library for the keypad, and we also have a class for the display, and we have a file for the memory. So if you're saving your minimum maximum voltage, your delay time and all that, so this is what is responsible for it. So we're just walking through the code. We just glance straight. When you're writing a complex code, you must know when to design a class, when to write a class, when to write a file, and when to create a library for it. So this is a very complex code. So we're able to split it, by creating two libraries, a class, a file, and there was an open source library we are using, which is the timer one. It's an open source, it's free. So that's what is going on right here. So then I just want to walk you through the library. You can see it. This is the library responsible for the keypad. You can see A, B, C, D, 1, 2, 3, 4, and all that. So this is what is responsible for it. So this library. And this one is for the voltage. To test. So we have two libraries anyway. We have one. If we are building maybe something like an energy meter, we have a library for that. That is going to maybe calculate the power, calculate the current and everything. So, but for this voltage guard intelligence, we just designed this library for that. It's going to read the AC voltage for it. So these are the code for the design. This is just for the display. This is for the control. When the user is controlling it, what is going on. So this is the code for it. So you can see it. This is the code for the control. So that's what is going on right here. So let me bring it back to the schematic. So in this schematic, each of these schematic of the component you're seeing, we design each of them, every one of them. We design it with a footprint and the 3D design as well. The 3D model for it. We're able to design it. So each of these things you're seeing here, like the LED, the R1, RGB and all that. So all those O's you're seeing, these are the footprint for it. So each of these components, we design everything. We have our own library for it. So this thing is being designed from scratch, So the reason for this is for precision, because you can go there, you can just go online, for instance, and get some of this component, but it might not be precise if you can design yours. So we just got to be precise with this design. So what is going on here is routing. So the board was manually routed, it's not like auto route here. So every line and traces you see here, it was routed by our team. So this board was manually routed. So that's what is good. This is KTech. So we're trying to include KTech to the library, and we're trying to use a B stop in the design. So this is for the PCB design. Now you can see after manufacturing, this is what you are expected to have. So that's what you can see at the CAN processor right here. So we check for errors, everything is good. Now I'm taking it to Fusion 360, then you understand what I'm talking about. You can see from the board, you see this thing you're seeing right here, like an LED, an IC, a button switch, and all that, a screen. Each of this was designed by our team. Like you can see the relay, you can see the transformer and all that. So every single one of these pieces was designed by our team. So the reason for this is for precision, like what I said. We're able to design each of these components. And why are we doing it this way? For final casing, this is going to help a lot. So from there, you're going to know, okay, this is how you're going to put the casing. So everything is going to be designed on the system, on the PC first. We're going to design the final casing on the PC. So if there's any error, it's easy to adjust. It's easy to figure it out. So that's just the advantage of doing it this way. Although it might look kind of complicated, but you're gonna have a good benefit for it. It's worth it. It's worth the time and energy that is spent on it. So this is a 3D representation of the design. That is, when we are done, making the board, this is what we should expect. So this is what you are seeing right here. We should expect something like this when we are done making the board. So that's just it, guys. So the program we use for this is Fusion 360. It's just like any 3D program out there, something like AutoCAD, SolidWorks, Fusion 360, depending on what you want to use it for. If you're into woodwork, I would advise you use SolidWorks. If you're into maybe architect, I would advise you use AutoCAD. Maybe if you're into electronics, I would advise you use something like Fusion 360. So the board has arrived. So you can see this is the board, and this is what we designed. This is the board. So let's try to make the board, and let's see if we are going to have what the 3D representation of the board. So that's going to be the next stage on this making of the board, that is putting the component on the board, soldering it, and all that. Let's start soldering, and let's see the final results on this. So let's go. So guys, what we're looking at now is let me just talk more about it. So this is a voltage guide intelligence. So we're doing some testing. So what does it do? You're going to find that in the next video, but I can just give you an heads up. It has the ability for you to set the minimum and the maximum voltage. It has the ability for you to set the delay before it trigger on. You can also password it. So we're trying to put it on a socket mode, putting it on a socket mode such that you don't need to have a wall socket. You just remove the wall socket and install this to it. So you can lock it. For instance, if the device is locked, nobody is going to use it except they know the password for it. So that's just a summary of what it does. So this is me making the board right now. You can see soldering is going on and everything. So you just got to be precise in your soldering. So let's see. You can see it's giving us the 3D representation of what we talked earlier. So this is what you can see right now. So this is the board itself. You can see it's just almost perfect, almost same. Like the difference is that we're going to have wires whereby we're going to connect it to the socket and all that. So what we are going to do now is I have a mind to maybe to 3D print a case for it because we are working on a good casing on this. So we just want to print a simple case for it. But I have a change of mind since this is a prototype. Let's just do a transparent casing for it. And so in that case, I went to Adobe Illustrator to see if I can design a vector file that I can use, that I can send to my CNC machine and all that to get it cut out. So let's see. So this is a vector file I'm trying to design using Illustrator. In this, Illustrator is not designed for this. The reason why I'm using Illustrator is I don't have a vector, VCarve. Sorry about that, VCarve. So if I had gotten VCarve, my life would be more easier. So means I just have to use Illustrator to see if I can get the lines, then take it to Easier or Lightborn to get it cut out. But since we are using acrylic, I did some tests. Uh, you know, the lesser cutter we are using is a diode laser. It cannot cut through glass. So I just have to use a CNC, to cut it out. So this is me still on Illustrator, trying to get the design right. Now this is Lightborn. So taking this to Lightborn, my life will be easy if diode laser can cut through anything transparent. But since it's a transparent casing, if it's something like maybe we're using something like black, red, blue, I can just use True Lightborn, use my atom stack to cut it. So, but the first thing I did was I just tried to use something like a light carton, to cut it out and see how it's going to look like, to see if there's any error was made. Then I can do the adjustment before cutting the actual material. So this is what is going on. So you can see I was trying to use light to cut through the acrylic. I will try to see if I can spray it both sides, but trust me, it didn't work out. So I have to take it to Easy, whereby I'm going to see I can generate a G code for this, because I cannot send this to my CNC directly. I have to generate a G code for it. Then I have to do some settings. I have to know the depth of cut. I have to do some, a rough and detailed cut. So I have to do the feed rate setting, the spindle setting, and everything. So I'm going to use Easy for it. But like what I said initially, if I've gotten something like maybe a VCarve, I can just do everything on it and maybe select everything. No need for me to use Illustrator, no need for me to come to Easy and all that. So everything is, is designed for that. But since I haven't gotten that software, I have to use Easy. So this is a universal G-code sender. So I'm sending it to this. But if I'm using VCarve, I don't need to also take it to this part. Everything is in but is since I don't do more of CNC work, maybe with time I'll see I can buy the software, the VCarve, try to work with it. So this is the machine now. It's doing its stuff. So it's gonna cut out the acrylic. You can see the machine is cutting out the acrylic. And another problem we're facing right here is the bait. I think there's a special bait for cutting acrylic, but the bait I have is for actually wood. So I have to put on my safety glass to protect my eyes and try to, get some of those cut out pieces using a blower. So that's what is going on. Hello guys. The reason why we are using this is just because of this, the first prototype on this. So we are trying we design on the actual casing I've started, so that when it come out, it's going to look like something like this. You can see this voltage guard, right? Most of you know this if you're in Nigeria. So it's going to come out clean, solid like this. So the company that is going to produce our casing for us, they are ready. They just want us to send our design. So our team right now, we have started, but just for the purpose of this, let's work with this for now. And let's see. And the reason why we're working with this, we are trying to see how we can make some adjustments to the design to see how we can make production more cheaper, and so that a lot of people can afford this device, So that's just it. We don't want to make something too expensive. We want to make it very, very affordable. So we are trying to see if we can do a lot of adjustments, and we'll also see if we can change some of these tool component to SMD component. So, but at this stage, you can see just the way we're able to do the panel of it. We can do anything, Is just like ABCD for me and my team right now. So what we need now is investors, and so that we can go into production and start selling this device to the public. So that's what is going on right now. So you can see, let's do some testing. Let's check the voltage that is reading with that of the multimeter. Let's see if we are close. And trust me, from my calculation, everything is good. You can see it's showing 210 and showing 210, 211. So we're cool. 209, 209. So everything is cool, guys. So the final design is going to be in form of a 2-socket mode. You know, it's almost something like this, smaller, clean, and sweet. So thank you, guys. Let's watch the next video.